just a quick question before we begin. How many people here are using GDID? Cool. How many people here are using Failover? Cool. And how many people here are using some kind of discovery service for the masters, like I don't know, console, computer, like that? Cool. I'll begin at the exam. More people. How many people coming to dinner tonight? Awesome. It's time. Hi, my name is Shlomi. I'm with the systems team at GitHub. I work on database infrastructure. I'm going to talk today about Orchestrator, which is a MySQL topology management tool. So Orchestrator is an open source project. I began working on it previous company, and this is my third company working on that same project. So I just want to acknowledge Alfred and Booking.com and now GitHub for letting me work on an open source project throughout different companies. So here's to open source. What I want to discuss is how Orchestrator treats failure scenarios, how it detects a master failure or any other sort of failure, why I think it does that in a more reliable way. I don't just think that, I also think and why it does promotions and recoveries in a much smarter way than what we have today also. So, Orchestrator, how many of you have never heard of Orchestrator before? Okay, cool. So Orchestrator is a tool that crawls through your MySQL topologies, through your replication tree. It pokes the master, shows slave hosts, it pokes the replicas, show slave status. It figures out what's connected where, and it builds internally the topology tree, and understands replication, and understands what's connected to what and how things should behave. So let's talk generally. We have a replication tree, and what could possibly go wrong? How do I know that something did in fact go wrong? How do how do you even know that your master has crashed? Right? So the common solution today is to use an idea like poking at the master, right? You port scan, or you actually connect to the server and you should select one, or maybe you actually update some rows to see that the master is responsive. And if you're using that and something fails, if you're only poking the master and something fails, how do you know that the master is indeed dead, or maybe you have a problem, maybe your monitoring site has a problem, right? So you're not sure, right? You're afraid of false positive. You don't auto-promote masters just like that, and you try again, and again and again. And so that's like the classic Nagios style, right? You wait like 4 times, 4 successive times means, okay, by now I'm really sure there's a master failure, and I do a promotion. So how many false negatives or false positives do you get from that? And how much time have you wasted in figuring out that the master is indeed dead? So Orchestrator takes a completely different approach, and I argue that it is very safe, very reliable, and much faster. So Orchestrator crawls through a topology, right? And it knows beforehand who is the master and who are the replicas, and what replicas from where, and how many slaves there were before the crash, and how many slaves were running and talking to the master just before the crash. So at the time of the crash, Orchestrator doesn't just observe the master, it also observes all the replicants, all the slaves everywhere around the topology. And he checks each and every one of them. And he says, well, what do you think? And it's not just issuing a select one or something like that. It's actually connecting to those replicas and saying, show slave status. What do you think? Show slave status. What do you think? process status? What do you think? Moreover, this is not limited to a master-only problem, right? Earlier on, Renee from Dropbox presented that they have a master in one DSC, a bunch of replicas, a local master or intermediate master in another DC, relaying replication to get other replicas. So what happens if that one goes down? How do you monitor that? How do you know that something went wrong? So in exact same way, Orchestrator monitors not only that server, but all these replicas. And it's asking everyone, what do you think about the situation? I don't know what I think, but what do you think? So here's a few scenarios. I'm going to walk through a few crash scenarios, and I'll explain how Orchestrator figures them out and reaches the correct conclusion. So say a dead intermediate master. What does that mean? It means Orchestrator cannot connect to that server, but that in itself is unreliable because maybe I have a connectivity problem. But Orchestrator is able to connect to those 3 replicas and is able to issue show slave status on those servers. And each and every one of those servers is saying, yeah, I can talk to the master. Something's gone terribly wrong. Well, that's I call this, right, the holistic approach, right? You get a full picture, like everybody is in agreement that something is terribly, terribly wrong. And you don't need to wait for 4 minutes or like again and again and again and again. If everybody is saying, yeah, we cannot replicate, and Orchestrator cannot see, de facto, there is no replication, right? De facto, I don't know what happened. Maybe that server thinks it's alive and replicating well, but no one acknowledges that, and everybody else suffers, hence a failure, right? This is a crash case. Just the same way, I cannot talk to the master, but I can talk to all of its direct replicas, and they're all saying, yeah, we cannot talk to the master. So that's the holistic approach. I get the full picture for everyone. And I don't need to wait for many cycles, because as soon as I actually suspect, as soon as Orchestrator suspects that there's a problem, like it cannot reach the master, or a first-tier slave says, I think I'm having issues with the master, Orchestrator immediately just goes everywhere and says, whoa, I think there's a panic scenario, what do you think? Right? So it doesn't need to wait for like the next cycle or anything. Whenever there's a hint of a real problem, a real danger, it just goes everywhere, all over the place, and asks everyone, well, what do you think? And with the proper settings for replicas, you can have like as small as 5 or 10 seconds until a replica actually figures out, yeah, the master is broken, or I can connect to the master. Things get more complicated when actually I cannot reach all of the replicas. What if I can't reach that one? Is it a correct conclusion to say that the master is dead? Maybe those 2 are broken, but the master is alive and I have a network problem talking to it. And that slave is also alive, and I have a network problem talking to it, and they're both actually happily replicated. So it's a matter of how many versus right, what makes sense. So what Orchestrator tries to do is figure out a natural human response. If I, as a human being, would see that situation, I would say, yeah, well, those 2 do say that they have a problem. And there's no replication running anyway. So maybe those 2 live happily together, but I don't think so. This is like way too dangerous for me. So that's a conclusion Orchestrator makes. Another thing I'm working on it right now is what happens if the master is deadlocked, right? We do an alter table or some trigger or whatever, right? I'm unable to write to the master. It's not processing anything because of some crazy law. The slaves are connected, right? But they're not getting anything through from the master. So they're all staying, right? They're not advancing in binary logs. They're not advancing in replication. This is something Orchestrator monitors today, and I'm working right now to make that a potential failure scenario. We might choose to fail the master because of that. right? We did a terrible outer table. If we try to roll back that outer table, it could just as well take 5 more hours to roll back that thing. We may just as well promote it in our system. Cool. So I claim that this is a very reliable analysis. This is used widely in production at my previous company, Booking.com. I don't work there anymore, so I'm not able to share numbers. Maybe my esteemed colleagues who sit in the crowd can share some later on. But this was like very, very, very accurate, right? When something went down, you would get a note from Orchestrator. You would get it minutes before Nagios would even alert you. And you wouldn't get false alerts. So I can't say, there's no 5 nines, 4 nines that I can say how much accuracy, because we don't have those numbers of production failures, thankfully. But it was very, 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 very accurate to the point of I really believe what was stressed. Okay, so we detected a failure. We came to the conclusion that we want to promote a new master. Let's talk about master, right? The master is there, and we want to promote a new one. Who do we promote and how do we do it? Is any of the replicas a valid candidate? Can we promote anyone we like? Well, not really. So this is the classic case, right? Replication is asynchronous. I'm not talking about Galera, but most of this actually applies to Galera as well, as long as you have multi-DC replication, because even with the Galera setup, you would have local Galera master on a remote DC, so you never get away from replication. So this is a typical scenario. The master dies. We have 3 replicas. Replication is asynchronous, so not all replicas are exactly up to date at the time of the crash. You have one that is most up to date, one that is less so, and one that is configured to lag by 24 hours for purposes of hackers and mistakes we do and we need to pull out some data. So you typically want to promote the one that is most up to date, because that one has all the relevant data as compared to others, and then put those 2 behind that one. Okay, so far? Cool. So that's the naive assumption. However, reality shows us that this doesn't play nicely. I might have 2 slaves configured with log slave updates, and another machine, which means I'm further writing the binary logs for future generations, and one without. Maybe it's a slower machine, maybe it's on Amazon, and it can perform too well, or whatever. And I just cannot, I must not promote that one on top of those 2, because that one doesn't have the necessary binary logs, even if it's more up to date than those other 2. What happens if I have multiple DCs? I really, really, really want to promote one of these because it's in the same DC, right? Promoting a slave from another DC, it's a bit more dangerous. Let's say I have statement-based replication, and I want to evaluate role-based replication, right? So we're getting into the world of real life. In real life, our system is dynamic, our state is dynamic. We're upgrading and we're checking new version and new configuration, and we don't necessarily have all things equal. So I would have one slave with role-based replication in the intention of, at some time, migrating from SBR to RBR. We must not promote that one because it just doesn't work. You cannot make SBR replicate from RBR. More limitations. I'm checking in on 5.7. I must not promote that one because I cannot or shouldn't. Maybe it will work, but it's very dangerous. Replicate from 5.7 to 5.6. So, what happens if we have multiple problems, right? This one is the most up-to-date, but in the wrong DC. This is less up-to-date in the right DC. This has no binary in the right DC. And Orchestrator actually figures all this out and tries to give you the best solution under the circumstances. So in this particular case, if all these slaves, like if these 2 have binary logs, fine. Orchestrator will promote most up-to-date. Will promote that one, putting those 2 behind, and then let them catch up, and then reverse the replication again. So it will do what you would do as a human being to make the best out of a situation, right? You really want that thing, but you have to go around to make that happen. And I'm still working on, if you take all the other conditions like RBRN, SBRN, 5.7 and 5.6 and 5.5, et cetera, et cetera, et cetera, that's like really, really complicated. So I'm still working on, making the best of the situation, combining all the potential problems. So what Orchestrator further supports is that it doesn't care about the particulars of your setup, right? While I developed Orchestrator in particular companies, I also worked on it to be a general purpose solution, right? And it will support GD80 and Sumo GD80, which is something that Orchestrator does as well. And it supports MySQL Beamlog servers, developed with Booking.com. And it supports row-based replication and statement-based replication, and Oracle, and MariaDB, and any combination that you might think of for all this, because it's really being built in production on many, many different environments. It actually supports all of them. You can ask it not to promote a specific server, if you like. And this is moving from configuration-based to state-based. You can ask for a particular server to be promoted if possible. And I'm working on more elaborate definition of what you may want to promote in case of failure. There's anti-flapping and acknowledgement. So you promoted a new master, and then you think it dies as well. Do you just keep on automated recovery until you've exhausted all your servers? Maybe there's a colossal problem with your system, right? And you don't want to get into this rabbit hole of, fall into this black hole. Eventually, you're going to run out of servers. So there's a flapping and anti-flapping mechanism which says, all right, there has to be a minimal amount of time between any two failovers on the same topology, or at least have a human acknowledge and say, okay, I'm marking this as okay, and you can go back resuming automated recovery. Just to put perspective into limitations, the one thing that Orchestrator does not give you today, and I'm working on that to some extent, because every company has its own setup, right? How do you detect a master? You have console, you have Azure Proxy, you have Puppet, you have, right? Orchestrator cannot possibly know what you have. And so the final step, when Orchestrator needs to fix a topology, it will heal the MySQL cluster itself, but to promote a server to be master makes a DNS change in your case, a VIP change in your case, right? Zookeeper update in your case, and it never ends. So it relies on your external hooks to make the final change. It will tell you, it will give you all the data you need. I promoted this or this, yada, yada, yada. But you would need to write the final step of actually making the change. And we're thinking about something that would be even more in the control of Orchestrator. It doesn't support multi-source, doesn't support the Valera this time. These are basically the high-level limitations. Just a few words about existing MySQL-specific solutions. So, when I say existing MySQL-specific solutions, those solutions that think about MySQL and promoting slaves, etc. Most of them today are configuration-based. So you specify beforehand the list of servers you would want to have in that setup. This is like operations unfriendly to the extent that I cannot stress enough, right? Because you're adding servers and dropping servers, and you cannot just go to configuration and type everything and deploy and hope that by the time this is deployed, everything's fine. I think it's the wrong way to do it. That's my opinion. Many of them assume a specific topology type. Like you would have a master, and you can only fail to that standby master, but you cannot promote anything else. I don't like that as well, personally. I just like, that's my topology, make the best of the situation. some solutions just assume that everything is Oracle MySQL or everything is MariaDB, right? But in reality, it's unfair to expect a specific setup where all servers are equal. We're all in the same version, and the sun is shining, and everyone's happy. That's not how we work, right? We upgrade, we change stuff. We want our system, our recoveries to be dynamic and adapting to our existing setup. I don't know of an existing MySQL solution that cares about intermediate master. It's always about the master recovery, never about intermediate master. I think it's a big issue. Intermediate masters are all over the place. Raise your hand if you have an intermediate master in a second DC. So, pat yourself on the back. Yeah. Because it's a sensible way to do it. None of the solutions I know have strict anti-flapping mechanism. Well, one of them has. I don't want to throw names around. I love everyone. I'm not saying Orchestrator is better than anything, but it's doing very well. One last thing to know is Orchestrator itself is highly available. That is, it's not the single point of failure. Orchestrator itself has a multiple service layout, where one of the Orchestrator services goes down, another comes up and continues from whenever the last one failed. Even if the failed one was in the middle of a recovery process and then broke, the next one will just say, oh, okay, forget it, I'm going to figure out everything again, because that's what I know how to do. I figure out stuff dynamically, so I'm just going to refigure out everything and do my thing. Orchestrator relies on MySQL backend, and there are 3 solutions to that, to have the MySQL backend for Orchestrator highly available. You can either use Galera for Orchestrator or MySQL Cluster for Orchestrator. I'm working on a solution that would actually allow you a normal master-master configuration availability. And there is some talk by other people, by third parties, to replace that with console and etc. But I don't know if that would happen. So I'm aiming to between 10 and 20 and up to 30 seconds complete recovery in the case of a real master failure without false positives as much as possible, and certainly without any false negatives. That's the purpose. And made a lot of advancement. Do I have a short minute? Yeah? Yes, a short minute. Renee was speaking here before about GDIDs and the time it takes for a slave to reconnect to the master, and how it might take like up to 2 minutes to just search for the GDID entry in the master, because you need to scan the binary log, which is 1 gigabyte now. And we've actually made very nice progress on that. We're like, Orchestrator is like indexing the binary logs as it goes along. And at the time of crash, it just remembers and it says, yeah, you know what? I don't need to scan the entire binary log. I can just scan, the last minute of the binary log, the last entries, because that's where the crash is likely to have happened. If it's not there, I'm going to rescan it. So I've reduced the recovery time by 30 seconds, which is a lot of time. Questions? Quick. Yes?
Short comment.
Yeah.
Your current limitations.
Yes.
Galera
Yes.
and multi-source.
Yes.
That would be the 2 things that I really would be implementing.
Yeah. I'm unlikely to implement multi-source.
Yeah.
I might go for Galera. I'm very much open to pull requests. I just moved into GitHub a couple months ago, so I'm a bit slow right now to accept pull requests. I need to, figure myself out again, so I'm a bit slow right now. There have been pull requests. Square are major contributors to Orchestrator, and it's working well, so I'm happy to do that. Orchestrator is known to work in production. Of course, the Booking.com and Outran, and GitHub, it's Square, GoDaddy, Box, SendGrid, a few others, big names that I forget, it's production. Yeah, let's take this offline. I wouldn't possibly be able to talk about that. Dinner tonight. MySQL and friends, community dinner.
Did you register already?
You pay 20 euros and then you're forced to eat croquettes. Croquettes. That's what friends want to do. Yeah. Okay. Thank you very much.